Welcome to BSc Statistics students. In this class, I explain one problem in PERT, Project Evaluation Review Technique. In the PERT analysis, I will tell you one particular problem. This is the problem. The time estimates are given for various activities, and we have to calculate the remaining, that is, the problems are given here. Activities here given, and T naught, which means optimistic time, and most likely time Tm, and pessimistic time Tp, which are given here. And we have to calculate expected time and variance of each activity, draw the network diagram, determine the critical path, what is the expected project length and variance of the project length, and what is the probability of completing the project in 125 days. These are the questions you have to answer, right? So for which I'm doing the first question, calculate expected time and variance for each activity. So this is the way to calculate the expected time and variance, right? You see here, probably it is required to calculate this, for which you have to draw this particular table. So expected time is T. The formula is T naught plus 4 Tm plus Tp divided by 6. This is expected time. And variance of each activity is sigma square is equal to Tp minus T naught divided by 6 whole square. So by using these two formula, we can calculate expected time and variance. For example, I will tell you the first one. This is T naught, this is Tm, this is Tp. These are the activities we know, 1 to 2, 1 to 3, etc. And T naught, that is 7, plus 4 into Tm, that is 4 into 9, plus Tp, that is plus 17, divided by 6. So you get certain value, this is 10. Like that, you please calculate remaining all the values. The values are, you calculate the values by using the formula. The values are here 25, 10, 70, 40, 60. I'm just noting the values. You please calculate by using the formula. Hope you understand. And 5, 50, 10, 30, and 40. So these are the values here. Expected times, that is TE, right? And then sigma square, variance. How to calculate variance? Tp minus T naught divided by 6 whole square. Tp is this 17 minus 7, that is 10, divided by 6 whole square. You will get the value. This is the value. This value is 2.78. Like that, you calculate remaining all the values. The 69.44, 2.78, 100, and then 11.11, 44.44, 1.78, 21.78. These are the values here. You please calculate the values by using the formula. Tp minus T naught divided by 6 whole square. This is 11.11. So these are the values we have calculated. That is, we have calculated for each activity the expected time and variance, right? So that is what is the first question was finished. Now the second question, draw the network diagram and the critical path. Third question, critical path. So I'm drawing the network diagram in the next page, right? Here I draw the network diagram. The second question, this is going to be answered here. The network diagram, this is very important. Network diagram in both the CPM and PERT. In both the CPM and PERT, it is required to calculate, that is, it required to draw the network diagram, and then you have to calculate, you have to find the critical path. So what are the activities? You refer the activities 1 to 2, 1 to 3, 1 to 4, which means I consider the event 1 here, that is the node 1 here. From 1 to, I represent the second node here, 1 to 2, and 1 to 3 I represent somewhere here the third event, and 1 to 4 I represent like this, and this is the activity 1 to 2, 1 to 3, 1 to 4. These are three activities I have represented with the time periods, or I'll tell you the time periods later, and then I consider 2 to 5, 2 to 6. There are two activities, 5 and 6. So I draw 2 to 5 here. Is it clear? 2 to 5 here, I'm considering fifth event here, and 2 to 6, I'm drawing somewhere here. It is after 5, I'm considering 6 here. 2 to 5, 2 to 6, I have drawn. And then 3 to 6, 3 to 7. Of course, this is very simple diagram. Simple network diagram. 3 to 6 here, I'm drawing somewhere here from, it is connected to from 3 and to 7. 3 to 7, I'm considering 5, 6 and 7. From 4, 3 to 6 and 3 to 7 I have drawn here, and 4 to 7 also we have. So therefore I'm taking one particular connection to from 4 to 7. So therefore it was finished like this. So it's very simple diagram, right? And then 5 to 8 and 6 to 8 and 7 to 8. 5 to 8, 6 to 8, 7 to 8. So we create 8, another node here 8, and so that you give the connection from 5, the 5 to 8, and from 6, 6 to 8, and from 7, 7 to 8. So three connections we have given. So probably the network diagram is very clear and very simple now for this problem, right? And you have to now take the time. What is the time duration? That is important, and in the PERT calculations, the time duration is nothing but you have to consider expected time, that is TE. This is what this column you have to consider for each activity. 1 to 2 it is 10, 1 to 3 25. These are the time estimates you have to consider as time duration in the network diagram from 1 to 2, that is for each activity. So I write in the network diagram, and so that so you see here, this is what the network diagram from 1 to 2, the duration is 10. From 1 to 3, that is the duration of this particular activity is 25, and 1 to 4 it is 10, and I'm representing above the arrow mark, and then the next 2 to 5 it is 70, and 2 to 6 it is 40, and 3 to 6 it is 60, and 3 to 7 it is 5, and 4 to 7 is 50, and 5 to 8 it is 10, and 6 to 8 it is 30, and 7 to 8 it is 40. Is it clear? Just now I have considered all the values of the expected times, that is time duration, in the PERT calculations. So this is the network diagram, and in which I have specified all the expected times for each and every activity, and then now I calculate the values of E's and L's by using the formula. The E1 is equal to L1 is equal to. By using the formula, I calculate here E1 and L1 like that. E2, L2, that is for at every event, what are the values of E and L, that is earliest times and latest times. So these are going to be specified, and at every particular node, that is at every particular event, we have to calculate this, that is earliest times and latest times are going to be calculated. How to calculate earliest times, which are to be calculated by using the forward pass calculations. And how to calculate latest times? Latest times are going to be calculated with the help of the backward pass calculations. And we have calculated that is in the CPM, that is critical path method. Many number of problems I have explained through this particular YouTube, right? Now I explain again here how to calculate the forward pass and backward pass calculations directly, and so that we can easily understand the values here, right? So now I start the forward pass calculations in this particular diagram, right? So in the diagram, if you consider here the values here, that is forward pass calculations means you have to calculate from first node to eighth node, the first event to eighth event. You have to move forward and then you have to calculate one by one the values. By considering E1 is equal to 0, you have to consider E1 is equal to 0 and then you have to move to the next node, next event. Second event, the second event, how many connections are there? How many connectors are there? Only one, that is 1 to 2. That is therefore 0 plus 10. The E plus Dij, Ei plus Dij. It's 0 plus 10, it is 10. Run, and then now from 1 to 3, move to the third event. Then the calculations are E plus Dij, that is 0 plus 25. It is again 25, we have only one connector. And then if we move to the fourth node, fourth event, then we have only one connector, therefore 0 plus 10, that is 10. Coming to the fifth one, we have only one connector, therefore 10 plus 70, E plus D, right? E2 plus D2, 5, 10 plus 70, it is 80. And then you have to move to the sixth event, that is we have two connectors, 2 to 6, I'm sorry, 3 to 6. 2 to 6 you calculate, 10 plus 40, it is 50, and 25 plus 60, 85, the maximum 85. You have to consider whenever you have more than one, you have to consider the maximum, right? You have to move to the next one, seventh one. Is it clear? Right, seventh one, we have two connectors, I'm sorry, 3 to 7 and 4 to 7. So 3 to 7, which means 25 plus 5, it is 30. Okay, we have to take maximum. 10 plus 50, it is 60. So you have to take the maximum, 60 is maximum. And then you have to move to the eighth, last one, last node. We have three connectors, 5 to 8, 6 to 8 and 7 to 8. Clear? So therefore you have to calculate the all the values and take maximum. 80 plus 10, that is 90, I'm writing here. And 85 plus 30, 6 to 8, that is E6 plus D6, 8. 85 plus 30, it is 115. And then E7 plus D7, 8. 60 plus 40, it is 100. The maximum is 115. So the maximum value is 115. So now you can easily understand, I tell you one particular point here, E8 115, which represents the total duration to complete the project. That is expected duration here in the PERT calculation, right? So 115. So this is what the forward pass calculation. By using forward pass calculations, we have calculated the values of E, right? And then now by using the backward pass calculations, now we calculate L values, that is latest times. Earliest times we have finished, now latest times. What is the formula for the end node? That is last one. For the last node, last event, E is equal to L. That is 8th node is the last node here. Therefore, E8 is equal to L8. That is 115. 115. So coming back to the 7th. So now we have to subtract L minus Dij. Right. So we have to calculate Lj minus Dij by using the formula, and if you have more than one, you have to consider minimum, right? So 107th node, 7th event, that is only one connection. Therefore 115 minus 40, 115 minus 40, it is 75. Okay, and coming to the sixth one, 115 minus 30, 115 minus only one connection, I'm sorry, first of all, only one connection, 6 to 8. Therefore 115 minus 30, it is 85. Coming to the fifth one, only one connection, 5 to 8. Therefore 115 minus 10, it is 105. Okay, and after 5, fifth node, then you have to go for move to the fourth node, that is fourth one. So therefore 4 to 7, only one connection. Therefore L is 75 minus 50, it is 25. Coming to the third one, we have two connectors from 6 and from 7, that is 3 to 6, 3 to 7. First we do 3 to 7, that is 75 minus 5. You have to take minimum. 75 minus 5, it is 70. 85 minus 60, it is 20, 25. So therefore the value is minimum is 25. Coming to the second one, E2. E2, the calculations are, there are two particular connectors, 2 to 5, 2 to 6. From 6 to coming back to 2 and 5 to coming back to 2. That is, we have to calculate both the two particular values and take minimum. 85L minus 40, it is 45. 105 minus 70, it is 35. So the minimum is 35. So therefore this value is 35. Last one, I have explained many number of times, that is L1 must be 0, right? Okay, anyhow we calculate. So last node is first node, that is last one, which means the first one here, for coming back to 8th node to last node, it's first node, right? So the calculations are, we have three connectors, 1 to 2, 1 to 3, 1 to 4, that is coming back from 2 to 1. That is there is another connection from 3 to 1 and 4 to 1, right? So therefore you have to calculate three values and take minimum, that is L 35. 35 minus 10, it is 25. Next, L3 minus D13, 25 minus 25, 0. And L4 minus D14, 25 minus 10, it is 15. So therefore minimum is 0. So therefore this is what the calculations of latest times, that is L, I or LJ, whatever it is, right? So all the values of L latest times we have calculated by using the backward pass calculations. So now we have finished the calculations, so time calculations. Then now we have to move to the identifying the critical activities and then critical path. So second question was answered, network diagram. Now we are moving to the third question, that is critical path. For critical path, I have explained many number of times that critical path is going to be identified by taking two particular events, that is an activity. If you connected to an activity that is which are connected by two particular events, for both the events it requires E should be equal to L, right? So you observe the activities here, E1 equals 0, L1 0, and third one, E3 L3 25 25, which are equal. Therefore this is a critical activity. 1 to 3, it is a critical activity. Okay, you observe 2, E2 L2 not equal, E4 L4 not equal. So like that you move to the E5 L5 not equal, E7 L7 not equal. Now E3 L3 equal and E6 L6 equal, that is 3 to 6, it is also a critical activity. What I have to consider here, I draw double line. So make double line, draw double line, so that 1 to 2, 1 to 3 and 3 to 6 are critical activities. And then E6 L6 are equal and E8 L8 are also equal. Therefore which are also comes under critical activity, that is 6 to 8, it is also should treat as a critical activity. Those three critical activities are present here. So therefore now we can identify the critical path, that is the critical path. I am writing the answer for the third question, that is the critical path. The critical path is nothing but 1 to 3 and 3 to 6 and 6 to 8. This is what the critical path for this particular problem, right? So we have answered third question. Both second and third questions are answered here. Hope you understand. I am moving to the next question. What is the next question? You see here, what is the expected project length? What is the expected project length? That is simply we can answer from the at last event, the value of E, that is earliest time. You can refer here, last event is 8, earliest time is E8 is equal to 115. Of course both are same here, E8 and L8. At the last event E and L are equal. That is our assumption. Okay, so this is what 115 days. If you represent in days, then it is in terms of days, that is the project length. The what we have to consider, the expected project length. expected project length, that is time duration, it is 115 days. And we have to see the next question. The answer is going to be provided here. That is the fifth question, the variance. Calculate variance of the project length. It is to be calculated with the help of the for which activities the variance is going to be observed here. The critical activities. What are the critical activities? And we have to add the variance of the critical activities. We have to consider critical activities, and for which you have to consider variance, and then you have to add. What are the critical activities? 1 to 3. So we have observed here in the network diagram that the critical activities are 1 to 3, 3 to 6, 6 to 8. So I am coming back. That is you observe from the table. It can be observed from the table that the critical activities are 1 to 3. That is the second one. So the variance is 69.44, and 3 to 6. This is the another critical activity. 3 to 6. 1, 2, 3, 4, 5, 6. Sixth one. After this 1, 2, 3. This is 44.44. This is the variance for this critical activity. And 6 to 8. That another one. The variance is 28.44. These, if you add these three variances, these are the variances for the critical activities 1 to 3, 3 to 6, 6 to 8. Therefore, if you add these three, you will get the variance. I answer here the variance. I answer here expected variance. Expected variance of the project length. Expected variance. Variance of the project length. Project length generally it is denoted by sigma square A. So it is going to be calculated by, it is equivalent to be for three critical activities which are going to be added 69.44 plus, that is one for 1 to 3. The variance for 3 to 6 is 44.44 plus the variance of the critical activity 6 to 8 is 28.44. Then the total is 142.32. This is what the variance, expected variance of project length, right? So, and then we have one more question to be answered. That you see the question here. What is the probability of completing the project in 125 days? So this is what the another question I answer here. Sixth question, in which what you have to consider, two particular times are going to be considered. Whatever the given that is given value, the number of days which is specified to complete the project in this question, which is called scheduled time, the scheduled time of completing the project. This is a schedule they have given, that is a company or an organization or an individual is given that and what is the probability of completing this particular project in 125 days, which means this is the specified schedule time. It is they require, they are asking to us. Therefore, it is denoted by TS. The schedule time is 125 days. And then now we have one particular expected completion time of the project, that is denoted by TE. Our expectation to complete the project is project duration is 115 days. We have just now calculated that is in the network diagram. Okay, through the network diagram, and by basing on our time calculations, this is what the expected completion time of the project. Okay, this is called TE. This is TS, schedule time. Expected completion time is TE, right? And we have one more value is required. It is to be considered as sigma E. Sigma E is going to be, it is nothing but we have just now calculated variance of the project length is sigma square. So that is called sigma square E. So I'll show you which is nothing but just now we have calculated, it is sigma square E. I explained that this is a probable value of sigma square E. The variance of the expected variance of the project length, it is sigma square is equal to 142.32, for which you have to take square root and so that you will get the value of sigma E. So sigma E is nothing but square root of 142.32. It is equivalent to be, this value is, if you do the square root, you will get 11.93. So this is the value of sigma E. Basing on these values, now we have to calculate the probability of, now I am calculating the probability of completing the project in the scheduled time 125 days. 125 days. It is going to be calculated by this probability of Z is less than or equal to Ts minus Te divided by sigma E. It is equivalent to be probability of Z is less than or equal to Ts is 125 minus Te is 115 divided by sigma E is 11.93. So this is what our calculations which are going to be considered, right? Is it clear? So this is equivalent to be, what we have to use for this, you have to use the normal probability law, and this value is 0.84. and if you see the areas property of normal distribution, this is a standard normal variate, Ts minus Te divided by sigma E. It is a standard normal variate, and basing on the by referring the areas property of normal distribution, we can calculate this probability for the values of 0.84. For the value 0.84, we can calculate, we can obtain this probability from the standard normal distribution tables. That is, the value is 0.7995. That is, our conclusion from this is the 80% of chances are there to complete the project in the scheduled time given in 125 days. That is the answer for this particular question. That is the answer for this question. That is the question here. Probability of completing the project in 125 days is 79.9%. That is 80% almost, approximately equal to 80%. 80% of chances are there. 80% of chances are there to complete the project in the scheduled time 125 days. This is what the answer for this question. Hope you understand. This is going to be considered from the taken from the standard normal tables, right? Hope you understand. This is what the problem in PERT. Thank you very much.